Data jobs tend to pay higher than a lot of other jobs. You get to use cool technologies. At the end, in most cases, like it's worth it.
Turns out having a strong network really plays a huge role in your ability to get new jobs, change roles. That just plays a huge impact on your career.
Welcome to the Data Career Podcast, the podcast that helps aspiring data professionals land their next data job. Here's your host, Avery Smith.
Welcome back to another episode of the Data Career Podcast. I'm joined today by a panel here. We're going to be talking about some very cool things about data tiles and operations research, which is a very interesting field in data science and analytics. We have Stephen Stark and Adam Dejans with us. Guys, welcome to the Data Career Podcast.
Thank you. Really excited to be here.
Yeah, likewise.
excited
Thanks
to
for
have
having
you.
us.
Yeah, for sure. Stephen, do you want to introduce yourself first, and then we'll have Adam go next? Just mention like what you currently do and maybe a little bit about your background.
Sure. So, hello everyone. My name is Stephen Stark, and I'm a senior data scientist with several years of experience. Currently working at American Tire Distributors. So, currently I work on a few major projects involving operations research in terms like inventory decision at distribution centers. And my background's in industrial operations engineer. I have a master's degree in the field from the University of Michigan. And I just really enjoy using mathematical programming to solve business.
Perfect. I like it. How about you, Adam?
So I'm in a decision science lead at Toyota North America, and I work in the supply chain, working in the digital transformation group. So we are trying to transform everything that we do within supply chain. So a lot of forecasting and optimization, all in order to all everything from how do you get the resources you need to build the car to building the car, what order you do it in, how do you schedule that, and then actually shipping that out to the customer as well.
Very cool. We're going to talk about, a little bit more about your guys' jobs here in a second. But one of the things as I was kind of prepping for this interview that I noticed, and I'll pull up your guys' LinkedIn here, the amount of titles that you guys have both held and that I've held is kind of insane. Basically, like there's analytical modeler, research assistant, business analytics engineer, statistical analyst, operations research scientist, senior data scientist. Adam, you have the AI consultant, which that seems crazy, decision scientist. You have the data scientist, operations research scientist, software engineer, data analyst, data mining research assistant, and software developer. I have data scientist, optimization engineer, chemometrician, and data analyst. And like, that's just like three of us. And it's like, we're not necessarily new to the fields, but we're not necessarily like have been in the field for millions of years. And if you think about it, like a dentist holds one title their whole career, like they are a dentist. But just between like the three of us, there's like 14 different titles. So I wanted to just quickly, I'll go to Adam first. Have your thoughts on like data titles. Like, what do you think about them? And like you mentioned before we got on the call that you've had more than that. Those are the ones you just put on your LinkedIn.
Yeah. So the titles are kind of, I'll call them mostly meaningless because every job you go to has a different title, and you could be doing pretty much the same thing job to job. It might be a different title, it might be the same title. Nothing really aligns. A lot of this has to do with a lot of the companies are still trying to figure out what it means to be a tech company or a data company, where they'll hire a data scientist, but they're not ready to do data science. So you're doing data engineering, or maybe you're just doing some analytics piece. As for myself, I kind of swapped around from software development. So I was in like more of a traditional software role, and then that progressed through more operations research mixed with data science. And then, like I said, I did that 1 year of consulting. That was a wild time. Consulting's a very interesting field. And then back to decision science. Even at Toyota, I've had multiple internal titles that have changed. Things from like analytics consultant, which is weird to have it as an internal title, principal, like principal engineer. I've had data scientist, decision scientist, a mix. So I just picked the most appropriate from what I think would fit in theory to match. So I don't have all these different titles.
I like it. You choose the one that fits, but maybe it's the one that sounds the sexiest. That's what you're going
That's
for
true
is
too. That's
yeah.
true too. Which one will get me? What one helps you stand out as well? Kind of
I
helps.
love it. How about you, Steven? Do you kind of agree that data titles are meaningless?
So I wouldn't say they're meaningless. So I think I mean Adam made a bunch of good points, and I want to emphasize that yeah, when it comes to a job, whether it's in data or not, I mean I think it's a lot more important that you enjoy the work and you feel like you're compensated well, and it's a good work environment, etc. Over like the title. The thing though is that like I think titles have values in terms of when you're actually trying to change jobs in terms of perception. Because let's just say a recruiter's on LinkedIn or a hiring manager on LinkedIn, they're just like scrolling through people. Now I don't know everything they see, but I feel like the titles themselves will stand out. So someone might just see a title and be like, oh, this person's a lead data scientist at company A, while this other person's only a senior data scientist at company B. So like, well, person A must be better. Like that's not necessarily the case, but when the recruiter doesn't have time to sit there and read everybody's, description and profile and resume and all that and in depth, like they might just jump to that conclusion. So I think that's probably like the most importance comes within titles, but then again, I think other components are more important, like the kind of work that you're doing and how you feel about your job and the compensation and whatnot. And going back to that too is that, like my current job that I'm in now, like I have the title of senior data scientist, but when I was applying to jobs, I had two offers, like the one that I'm currently in now, and another one that was called like staff data scientist. So, like even though like most people would say, oh well, staff sounds better than senior. Well, I mean the compensation and like the work and whatnot, I felt like was better at my current job than the staff role that I turned down. So I mean, yeah, there's definitely more to life than titles.
You also bring a good point that like even like the I don't know what the correct term for this is. I'm going to call it the prefix, like the lead, the staff, the junior. Even that stuff is a bunch of bogus. I've had a company that we've actually put a lot of our students into out of our boot camp that they've hired our students, and they hire all of our new students who are brand new to the field, a lot of like transitioning teachers. Some people didn't even have college degrees, and they all become a senior analytics associate. I don't know what an analytics associate is and what makes you a senior one, but like even the prefix on things can be kind of wild and silly. I want to go back to what Adam said earlier, where like, you try to choose the title when you put it on your resume or on your LinkedIn that best represents what you did. Do you think it'd be okay for someone like, do you think you have to stick to the official title that was given you? Or if you're given kind of a wacky title to kind of maybe more generalize it or dumb it down?
I think it's okay to switch it. I like to switch it to fit what I actually do. So if it aligns closer to what I do, then that's what I'll choose. I think like right now, currently, my title's like principal engineer something something. I don't really do engineering at all. Software engineering maybe, but if you just see principal engineer, what does that mean? so so it's like one, I want to be more descriptive to let recruiters or other people know what I'm doing or what's closest to what I'm doing. So I think there's some wiggle room there. Now you can't totally I'm not saying fabricate what you do, but if you can get a different title that aligns more to what you're doing and it's not a big stretch, then I think that's acceptable, especially on LinkedIn.
I agree. Like when I was a chemometrician, no one even knows what that is. And then I'm like, oh, I'm a data scientist who does stuff with chemistry. Oh, okay. That makes more sense. Stephen, I was curious though, out of all these different jobs that you've had, is there one that you like more than the other? Like, for instance, do you like being a data scientist more than doing like an operations scientist role? Or has it kind of all just been enjoyable one way or another?
So I guess this is going back to what Adam was saying before, where it's like you can have like a different title but still do the same kind of work. Because like I mean, yeah, in general, in terms of like the kind of work, I'd rather do like mathematical optimization, like prescriptive analytics over predictive analytics, like machine learning trying to predict something. But I mean, at the end of the day, like all the roles, like it's more so focused on like, okay, here's what the business has, this is what the business needs you to do now, and like, it's like you don't always necessarily get to pick and choose like, oh, I get to work on this type of problem or that type of problem. It's like, well, here's the priorities, like you need to do them. So like you can't just be like I don't want to say one trick pony, but there's like a variety of skill sets you need where, especially whether you're like data scientists or like operations research scientists, you're going to be working with databases. So like you're going to need to know SQL. And then also like, to like, being able to like work with business stakeholders, like ask clarifying questions, being in the loop and having good communication skills, like those are all going to be relevant. So, but then like I guess like in terms of when you're asking like the jobs, like I've been fortunate enough that like all my jobs have been like pretty good experiences for the most part. I One thing I will acknowledge that in terms of, like the product slash service itself is that at my previous company when I worked at NBC Sports Next, which is a part of NBC Universal, I just thought that was I thought it was really cool. Like everything that's behind the NBC brand, like like the parks and the movies and TV shows and whatnot. So in terms of, like coolness brand, I'd say that one so far. Not that the other brands I've worked for were bad or anything. Like I just thought the entertainment industry is pretty interesting.
I would agree with that. And I'm a basketball fan, and the NBA just bought back the rights to the NBA. Or sorry, NBC just bought back the rights to the NBA. So I think that would be an exciting time as well. Now, I pride myself. One of the things I try to do on this podcast is there's quite a few data podcasts out there. I always try to make this podcast as beginner friendly as I can. And we've said a lot of fancy terms that I would love your guys' help in defining and talking about, because I don't think a lot of people know them necessarily. So maybe I'll start with you, Adam. We've said the phrase operations research a lot. Can you like give like and explain like I'm five definition of what operations research is?
Sure. So when I think of operations research, I think of there's some decision that needs to be made, and you're trying to figure out what is the best decision to be made. So it's easier to compare it to something like data science or machine learning that people are used to. So with machine learning, you're usually doing something that's more predictive analytics. So you're building models around, trying to predict something, maybe trying to forecast something. How many sales will I have? How do I recommend, like, maybe I'm building a recommendation engine, or I'm trying to see like what story does the data tell, but you're not focused on an actual final decision. So I think that's one of the key differences. In operations research, you'll hear of mathematical optimization, and if you're unfamiliar with that, there's some objective that you're trying to maximize or minimize. There's some decision variables, like what can you change in the course of this problem? And then there's some constraints on it as well. So, for example, if you're staffing people, maybe nobody can work more than 40 hours. So I think the key focus there in operations research is there's something you're trying to decide, so you'll use things like I said, mathematical optimization or mathematical programming, simulations, and also you focus on some of the psychology that goes on with your stakeholders. So that those are really the big differences between what is traditionally considered data science versus operations research.
I like it. Steven, anything to add to that?
I guess if I had to describe it in one sentence, which might sound like pretty nebulous, I'd say it's the use of math, technology, and logical reasoning to solve business problems intelligently.
I like it. That's a nice sentence right there. Steven's very passionate about it. By the way, we'll have Steven and Adam's LinkedIn URLs in the show notes down below, and you guys can go follow them on LinkedIn. They create a lot of content. Steven is very passionate. In fact, he made a LinkedIn post that got a lot of traction here, and I want to read it. He said, "Unfortunately, the most interesting part of data science doesn't get the coverage it deserves. I don't mean machine learning, although machine learning does depend on this thing. I don't mean SQL either. SQL gets more coverage than it needs. Yes, SQL is important, but it's not as exciting as people make it out to be. What I'm talking about is mathematical optimization." And if you guys just heard that, I don't know about you, Stephen and Adam. I just heard the whole audience yawn as they heard that. That's okay. He says, "I believe the reason why people don't get enough coverage is simply because not enough people know about it. Mathematical optimization is typically covered, in the following undergraduate/graduate programs: industrial engineering, operations research, mathematics, and computer science. And it may be touched in the following subjects as chemical engineering, economics, and business." And here are some use cases. So I wanted to go through some of these use cases one by one and talk about what the examples are. So one of the ones, actually, we should probably talk about the ones that you guys can talk about more. So one of the easiest ones to talk about is like inventory. You know, how much inventory should a company hold? Like, let's say we're selling. I guess the easiest one that I always talk about is like ice creams. If you're like an ice cream vendor in like New York City out on the street, how many little cups of ice cream should you have? Because if you don't have enough, right? If you don't have enough ice creams there, you're going to potentially miss out on business. Because if you sell out oh, well, crap. So, you sell out maybe at like noon, you're going to miss, noon to 5 p.m.'s business and you're not going to have enough money. Let's say you come back the next day and you packed a lot of ice creams. Well, if you have a lot of ice creams and you don't sell them all, let's say it's 7 p.m., you're going home for the day and you have 400 ice creams left over. Those ice creams might melt, they might expire, so you might lose money there. So basically, one of the things that operations research does is take a look at this problem and basically tell you what the optimal amount of ice creams to have at your little cart that day. Adam, is that the type of problems you've solved in the past? Does that kind of make sense? Can you maybe relate to us what you've worked on in operations research?
Yeah, I've worked on inventory optimization like that. And one thing I want to point out is nowadays, it's not just the optimization by itself. A lot of the predictive analytics feed into optimization. So, for example, you want to find the optimal inventory, but how do you come to that conclusion? You need that predictive analytics piece to forecast, how many ice creams you think you're going to sell, maybe. And then there's some statistics, probability thrown in there. But another really good example that is really easy for anybody to understand that I've worked with Stephen on this as well, is the vehicle routing problems. So they're very intuitive. You have a bunch of people, you need to pick them up and drop them off somewhere. Every car can only hold so many people. Like, what's the best route to go to do this? And when we say best, what do we mean? We could mean we want to minimize number of miles driven. So when I worked in autonomous vehicles, that was really important because the more miles you drive, the more wear it has on the car. And autonomous vehicles, you do not want to have to repair them. Like, they're very costly. Or if you're looking for really good customer service, maybe you're trying to minimize the time it takes from them to put in their request to be picked up to get where they're going. Or maybe you want to minimize the cost for the customer. So then you can factor in something like ride sharing. But that's a very easy example, right? You're just picking people up and dropping them off. But coming up with that optimal sequence of pickups and drop offs turns out to be quite challenging. And maybe people have heard of the traveling salesman problem. It's very similar, but it's like traveling salesman on steroids, right? Because each vehicle is doing like its own, almost like it's solving its own little traveling salesman problem. Not exactly, but it's quite similar.
That's a great example. For instance, like Uber, how does Uber decide where like people get picked up? Or I guess they don't decide where people get picked up and dropped off, but like how are the cars allocated in that
Right.
situation? And like you said, with autonomous driving, kind of the same deal. Thank you for that example.
There,
Go ahead, Adam.
I was gonna say there's a huge change management factor in there as well, because like a lot of people think, oh, just go to the closest vehicle, right? But that's what your intuition thinks, like pick up the closest person, but that's not always the case. So you need to also work with stakeholders on that, and that's more of where like the operations research. When I said the psychology piece also plays a role, because you need to be able to explain why am I not like somebody put in a request 20 feet away. There's a car right there. Why didn't you send that car? Why'd you send this other car?
That's a big one because I guess one of the differences a lot of the times, not always, but with operations research is, I think Stephen's definition really captured this well, is you're trying to make informed business decisions, but at the end of the day, the humans still making a lot of the decisions. When I worked at ExxonMobil, the operations research problem I worked with is what crude oil do we buy from different parts of the world? We're trying to figure out if we're going to make all these different products with the current prices of all these different crude oils and all their chemical properties, what allocation of crude oil should we buy to maximize profit, minimize emissions, stuff like that. And at the end of the day, the computers, it's not like an algorithm that's automatically making the trades for, the calls for purchasing the crude oil. It's still a human being. And a lot of times the human being that was doing this had been doing it for 20 years. And so you have to deal with, well, my gut's telling me this. Why is the computer telling me that? And so that's a lot of operations research, like you talked about, is like being able to have some sort of explainability and like, this is why the computer thinks this is a good idea. Do you approve as a human? So that definitely is a part of it, is like explaining. Stephen, I wanted to go to you and just hear like what you've kind of worked on in operations research.
Um, sure. So I'll use an example similar to, related to what you were just talking about, where the explain to human part. So when I was at Walmart, I worked with a team, and we had a problem of, as new items would come into a warehouse from Walmart suppliers, we have to find shelving for them in the distribution center. And the idea is that, there's different shelving, and the different shelving has different sizes. And there's certain constraints, like really heavy items can't be on the top shelf because, someone could get hurt trying to take them off the top shelf. You can't have very similar looking items next to each other, because if you do, the person that takes the item off the shelf and puts it in the box under the store, they might accidentally take the wrong item. So like, how do we place the item such that we avoid those issues? And then also too, where it's like, you might have to take one item out of its current spot and then move it to a different place. And it's like, that's going to, that results in a lot of walking and, work hours. Like, do we want to do that? We only want to do it if it's necessary. And with that, the press that we were taking over was that like one person would just look at a report and make, okay, here are new items that would come in. And this manager, she'd just like manually walk to each, open shelf. And then it's like, get some measurements and try to put them in there. It's like, this process was like really like hard, because, a human being can't process all this information at once. They can't keep track of like all these hundreds of new items that are coming in. So it'll need to, not optimal solutions. But there's like a psychology as part, as Am mentioned before, because we had to, explain to this person where it's like, okay, like this technique that we're using, it's not going to take your job away. Like, you're still going to have your role. It's going to help streamline your role so that you can focus on like more important problems at the distribution side. Because like once we automate this problem, there's other problems that we currently can't handle yet, but like you'll be able to handle those instead. The big thing too is that like explain to people that there might be a decision that it looks like it's not good for this one like small portion, but it's actually best for the whole system. I think that's like what's really challenging to describe, because like some people might just think like, oh, well, the absolute best. And when I say like for the whole system, it's like, let's just say, for instance, when it comes like the packing, you're putting items on a shelf, you might have like one item that's like you put on a shelf, but there's like a lot of room left over, and you might be like, well, that item should go on a better fitting shelf. Well, it turns out that by putting that item there, all the other shelving like is like more efficient. So like as a whole, it's better than trying to get that one particular item. It's like best fitting shelf.
Yeah, it's making tough decisions. Basically, it's making these decisions across thousands or maybe even millions of other decisions. I can't believe we're like 20 minutes into this, and I know Stephen mentioned it earlier, but quickly, there's 4 different types of analytics. Descriptive is what happened in the past. So like, for instance, if we take Stephen's example, well, maybe Stephen's example is hard, but like what did customers buy, for example? What's popular at the store? That's descriptive analytics. And then there is diagnostic, which is like talking about like maybe why customers bought those things, like, or how. Then there's predictive of what will they buy in the future. And then there's prescriptive, which is like how to get stuff done. Like, where should we put this stuff inside of the store? So that's something that's noticed. And that prescriptive analytics is really a big part of operations research. That's kind of where operations research kind of lives. Now, these jobs that you do inside of operations research, they're great jobs. You're solving interesting problems. Like, for instance, what oil should we buy? Where should we put stuff on the shelf? What parts do we need, at our manufacturing company? Where do we source them? Stuff like that. But one of the things I asked Stephen and Adam, that we try to be user-friendly, beginner-friendly at the podcast, is like, could someone who's transitioning from like a completely different career, has a non-technical background, could they potentially land in operations research as their first data job? And so we kind of like had a quick conversation about this earlier, but Adam, I'd love to kind of hear your thoughts of like, let's say there's a high school math teacher who wants to get out of the classroom. Could they potentially land in operations research as their first data job?
Let's say that it is a math teacher. They have a math background. They have the foundation that's necessary to do this role. They're probably missing a few operations research courses. Let's just say they go and study that on their own. They're still going to face the issue of having that piece of paper. So, particularly with operations research, there's a huge emphasis on having a PhD. Even just having a master's is barely enough a lot of the times. I don't think I've seen really any role outside of government roles where only a bachelor's is required. Usually there's some type of graduate degree with a very strong preference toward doctorate degree. So there's like could they do it? Do they have the skill to do it versus the practical piece of getting past the HR gate?
Stephen, thoughts?
I think it was like 12 people total. There were 3 masters, me and Adam being 2 of them, and then a good friend of ours, and then like 9 PhDs. And my other teams I've joined, at least masters and above. So yeah, I mean, there is a big emphasis on graduate degrees now. If it was like a high school math teacher, if they already had like a master's degree in math, I think that would that would probably satisfy the degree requirement. But then again, it's just brushing up on certain topics that they might not have studied or it might not be as fresh in their head.
That team that he's referring to, like almost all of them went to really big, well-known universities as well. So it wasn't like some random college.
I wouldn't want to like have the graduate degree be like, and that's like a turn off because, and it's not easy, but like there are places where that have like 1 year masters or ways like make it more affordable. So like for instance, a lot of my friends that did masters with me at the University of Michigan, they had multiple semesters of it being like a research assistant or a graduate student instructor, and in those cases, like in exchange for working, it's like a graduate student instructor. People probably know it's like the graduate students that like helps out the professor in teaching the course. They grade papers, things like that. They can have their tuition waived and also get paid on top of that. So those are opportunities too. Now, again, like I understand too that like you might have a family, you might have other commitments, and you might have but other commitments. So it's like it might be hard, but like there's different avenues and like because like there are sometimes on LinkedIn I just people say things like, "Oh, graduate degree, no, I can't do it." Or whatever. I feel like it's more attainable than some people make it out to be. Like it's not as I don't think the work is necessarily as bad as some people make it out to be. Now, a PhD like that might be a lot, but even like a 1 year or like 1.5 year masters, I think are for the most part like, pretty doable and flexible, and even like allow you to take it online or like do part time or something. So like you can still have time for your job and like other commitments and whatnot.
I agree with you. I mean, my master's was 2 years part-time online. It wasn't like the hardest thing on planet Earth. And you guys are totally right that like a lot of operations research, they're pretty stingy with needing at least a master's degree. I will say that if we go back to some of the programs that Stephen mentioned in his LinkedIn post, for example, if you studied industrial engineering, if you studied operations research, I don't see that degree too often. If you studied math, computer science, chemical engineering, economics, maybe like a more technical business degree, there's a chance that you could potentially as an undergrad. So for example, after my undergrad, I landed my job at ExxonMobil in operations research, and I only had an undergrad at the time. I ended up getting my master's while I was there. I mean, I landed an operations research job without the master's degree, but I wouldn't have been able to technically climb the corporate ladder as high in that team because I didn't have like a master's or a PhD. If you already have a master's, then you're set. If you have a PhD and you're trying to break into data, this is probably one of the best places for you to be. If you're like an elementary school teacher or you're an Uber driver or like you're a cashier or a bank teller, probably not necessarily the best place to look for your first data job, maybe your second data job based off of experience. But one of the interesting things that we talked about earlier, Adam, was that like in the end, I don't know about you guys, one of the jobs I did operations research, we used a proprietary third-party tool to do a lot of optimization and thinking. So a lot of the times I was just using Excel to put stuff into that proprietary software. I've been at a company where we've used Python to do our optimization. That was a little bit more involved. But a lot of the times we're using pretty simple models. Adam, like what type of tools have you used in your different companies?
Yeah, as far as operations research, a lot of the tools we use are those solver. Well, if you're doing a linear integer programming problem, like you're not going to write your own solver that beats the leaders, right? The Gurobi, Cplex. But they're and a lot of the problems that you work on are quite simple. Stephen will tell you stories about that. But like a lot of the optimization problems are very quite simple. I've had one though, the vehicle routing problem where it was a real time vehicle routing problem.
Oh,
So I
yeah.
had to have a super fast response time that required custom algorithms, and that took a lot of there's a lot of computer science work. We had to write it in Java, right? Python might be too slow for that, so it's like a custom meta heuristic written in Java to solve that. But outside of that, a lot of the problems you work on are not too complicated. And a lot of, even when they are complicated, it goes into the modeling piece, not really like the mathematical model. If you can write it down on paper, you can use some third party solver to solve it. It's kind of like when you do an interview, you do some crazy technical screen and then you get the job and you're making a CRUD app. You just like reading and updating a database. So that's what happens. Yeah.
I felt kind of the same. Stephen, you're using a lot of third-party solver stuff as well?
In my current job, no. But actually, yeah. Oh, okay. Well, sorry. I was thinking of like open source versus like commercial solvers. Like, but I mean, yeah, mostly commercial solvers. Like, as Adam mentioned, things like Cplex and Groby I've used in past jobs. And then other ones, I've also used open source ones, um, such as, I know the Python, like Python has like a variety of packages, like Pulp and Pymo,
Cool.
where you can form the problem in them, but then they can call solvers. A popular open source one is Higgs. I forgot what it. I feel bad because I forgot off the top of my head like what it's short for. But that's a nice open source one. But then like in addition, like the solving tools, like there's also, we are also going to use like Excel, Python, SQL, like cloud computing services like GCP and AWS. Yeah, those are just some common ones. But then also too, like another thing is that going back to some of these problems, like sometimes you can't just like use a solver to solve because you might need a solution like very quickly. So sometimes you might need to write your own like heuristic to solve a problem. And like to use like simple terms, like a heuristic is like like a smart way that's like not guaranteed to find the optimal solution, but like the idea is you write an algorithm that like find like good solution quickly. It's like having to write my own stuff in Python like that too.
But as far as simple problems, can you bring up like some of the problems that we've seen in practice are like a few decision variables, right? Like it's not anything complicated.
Or, I mean, yeah, there was one at a past job where it's like the complicated stuff was not like the optimism, like it was like pricing for golf courses, and like the actual model itself didn't have like tens of thousands of decision variables. The more so complicated stuff was just like making sure we were like having like the right sensitivity of pricing, where it's like, okay, well if we up the price by this much, like how much will that actually affect demand? So like, yeah, some of the stuff outside the optimization was a lot harder than like the actual like, mathematical model itself.
It's pretty cool because after you've created this model, which once again, a lot of the times, like Adam kind of hinted at earlier, you have to use predictive modeling to create a mathematical model. For example, like when I was at the refinery, right? It's not like you can just like magically have like the exact rules of a refinery with like literally tens of thousands of variables and stuff. Like you have to use mathematical, let's just say predictive analytics, to try to figure out like how to predict how the refinery is going to act. And then you use prescriptive analytics to try to figure out how to work it optimally. But it's pretty cool because you basically create like I don't know, like the right term, like a digital version of something that exists in real life. So for example, what Steven's talking about is like you create like a digital version of this golf course, and it's almost like you play Sims and you like try to like, oh, well, what happens if I crank up the price? Do I make more money or less money? What happens if we do, I don't know, what do you do at a golf course other than change the price? But like you can like basically like create almost like a Sims version of your business, and you can kind of hand it to business leaders and be like, hey, play with this lever, move this lever up and down, and we'll try to tell you what will happen. It's almost like predicting the future, or at least allowing you to like almost run a simulation of being like, this is probably what will happen if you have this here, this here and that there. It's a pretty cool tool that, like Steven said in his LinkedIn post, is pretty underappreciated in the data world.
They'll call those digital twins, by the way.
That's the term I was looking for.
That's the term you're trying. You almost had it.
It's been a while. Yeah, a digital twin. Yeah, exactly, which is pretty sweet. Anything else that the people should know about operations research and prescriptive analytics?
Sure, I have something. So you actually made like a YouTube video like a while ago about this, but like a good introduction is the diet problem. So the idea is that like each day, and like there might be like small variants of it. So I might I might change some of the details, but the idea is like, okay, so like each day you have to eat, obviously we all have to eat food because, we need to eat food to live. And, there's certain nutrients you want, and there's certain food, and, there's a variety of food items that you can pick which food items you eat such that it costs the least amount of money, but you satisfy, calorie and vitamin requirements, etc. That's like a very nice, easy to understand optimization problem. That's something where you can just like Google like the diet problem, and there's like a lot of like resources and videos on it, including Avery, your own interesting video where you actually went to McDonald's, like use the diet problem model to determine what you're going to eat there.
Yeah, we'll have a link to that. But yeah, I tried to find the McHealthiest combo meal that there possibly could have been using operations research. The answer was like not very exciting. It was like 5 like Dr. Peppers. I don't think water was an option. So 5 diet Dr. Peppers, like 2 salads, an apple, like a couple apple slices, and that was like it or something. So it was not very exciting. But yeah, operations research is very powerful. I want to ask you guys one last question, and if you can go back and tell yourself something when you guys were first starting analytics, what would you tell yourself? Like, how would you, like, what advice would you give your younger self in the field? Adam will go first, and then we'll go to Steven.
Not even data related, but one would just be one is to network, actually, like meeting people and networking more. So when I was in school studying, I probably would have studied less and talked more to others. Turns out having a strong network really plays a huge role in your ability to get new jobs, change roles. A lot of the openings that you see are I'm not based this is not a real statistic, but it seems like half the time there's a role, it's usually filled by an internal reference. So that just plays a huge impact on your career. As far as the data side, um, when I studied math, nobody told me that I had to go to graduate school, so that was I didn't know what I was doing. I just showed up and went to school. But yeah, I think as you progress throughout your career, like the people side of things makes a huge difference. So I'd probably focus more on that and less on the technical side.
I love that. I don't know how familiar you are with our podcast, but we talk about the SPN method: skills, portfolio, network. And they're basically a third of the equation of landing good jobs. So I love that. Your advice is not even the skills part, it's not even the data part. It's all about the networking. I totally agree. Steven, how about you?
It's okay. It's hard for me to give my younger self advice, so I guess I would change it to give advice to like folks more so just folks breaking into data because like there are times like people might like see something they might have like heard some of the content they were talking about and like be intimidated or scared about it, but I just think it's like data, whether it's like operations research focus or even like visualization, engineering, machine learning, etc. I think it's like pretty fun, interesting, exciting that there's like a lot of good roles. And for the most part, I have trouble seeing myself doing any other kind of job. Like I couldn't see myself just being like a project manager and something. Now other people want to do that's completely fine. So like my thing would be like don't get discouraged if you're trying to learn something and like you're finding it hard. Like, we all start from the beginning at some point, or we all had to. So like if you're like struggling with like SQL at first, or not, like just keep at it. Realize that it's gonna take time to learn. A lot similarly with like Python or some of these other mathematics topics, and that there's a lot of like people you can reach out to on LinkedIn. There's like a lot of resources. There's your boot camp and whatnot to help break into data. My big thing is like if you're truly interested in like doing a job in data, then pursue it. Don't get discouraged. Like don't let discourage or be intimidated by something. Like just go do it.
I love that. And I think it's really important coming from that message coming from you guys. I'm considering we just talked for 40 minutes about like PhD level math type of equations. But the point that I think you're saying is like, even though that's, what we studied, it's what we kind of do. It's like you actually get to the job. Once you get past the interview, everything's kind of easier than the actual interview, like a lot of the time, at least from a technical perspective. That's not always true, but it's true a lot. And I like what you said, like, don't be discouraged because we all used to suck at everything that we used to do, and you just get better with it at times. So
Also, and to add on to that is that like I feel like it's worth it at the end because you hear all these people like complain about jobs and things like that, and like looking back at it, I realize like it's a pretty cool job. Like in general, I think like data jobs tend to pay higher than a lot of other jobs. Like I feel like the work life balance is like better than like more businessy jobs. You work on challenging problems. I think you get to use cool technology. So and yeah, so my thing is like if you're interested in data, pursue it. And also, I think at the end, in most cases, like it's worth it.
this is worth the squeeze.
Yeah.
I like it. It is a pretty cush job. You get paid a lot. You don't have to, the deadlines are like pretty manageable. You get to like work remote a lot of the time. So
Okay, so I agree in the sense like that's like been my experience what you just described, but then like I'm sure like other people unfortunately in data like they might have had different experiences, but I mean still I'm a big proponent of the type of work.
yeah, of course, there's bad apples in every industry. I think that's for sure. Okay, well, thank you so much, Adam and Steven, for coming on the podcast. If you guys want to connect with these people or follow them on LinkedIn, we'll have their LinkedIn URLs in the show notes down below. You guys can follow them. They're posting great stuff about data careers as well as things like operations research. So if you listen to this and you're like, yes, operation research is the right path for me, follow these people. Steven, Adam, thank you guys so much.
Thank you.
Yeah, thank you. It was a fun conversation.